Plants cannot absorb the nitrogen directly from the atmosphere because its equation from the atmosphere requires breaking of an exceptionally stable triple covalent bond between the two nitrogen atoms. Thus, it must be fixed in the utilizable forms, that is ammonia and nitrates. It is available high amount in the atmosphere. It is most critical element for the plant growth. Nitrogen is one of the most important element for the plant growth, as it is present in the compound like proteins, vitamins, enzymes, alkaloids, nucleic acid, and chlorophyll. Its deficiency causes chlorosis and stop the cell division and elongation, thus retards the growth. Plants gets nitrogen, fixed nitrogen by two sources. One is symbiotic, another one is asymbiotic. In case of symbionts, the ammonia is taken up by host immediately and assimilated. In case of free living nitrogen fixers, the fixed nitrogen is released by their death and decay in the form of nitrates and ammonia through ammonification and nitrification. Decay causing organisms like example Bacillus ramosus, Bacillus vulgaris, and Actinomycetes converts the dead bodies of organisms and as well as other organic matter into organic matter and ammonia. Ammonification. In ammonification, so proteins proteins in the presence of water, they become amino acids. So in the presence of the H2O, that it become the amino acids. Again organic acid. So again in the presence of water it become a organic acid. Organic acid. Organic acid plus ammonia. When dead bodies of the protein in the presence of the water, this become the amino acid, then it turns into the organic acid and ammonia. So finally we will get the organic acid and ammonia in the by decay and dead bodies of the proteins. So whether it is plant or animal doesn't matter, but all proteins converted finally amino acid, then organic acid and ammonia finally. Natural fixation occur by one is electrical, one is electric discharge, abiological nitrogen fixation. Nitrogen abiological nitrogen fixation. Abiological nitrogen fixation occur either by naturally or industrial process. Natural fixation occur by electric discharge. One is electric discharge, electric discharge. Second one is ozonization, and third combustion. So in three ways natural fixation occurs. This process, different types of oxides of nitrogen are formed. Means whatever oxygenated compounds, NO, NO3, NO2 minus, like that. So different, whatever oxygen is present in those compounds, after formation of the oxides of the nitrogen, they come to the soil by the means of mixing with the rainwater. During the rainy season, thunders come now. So that time what will be nitrogen and oxygen together, electric discharge. Electric discharge, with the electric discharge, they are formed as a nitric oxide. So whenever during the rainy season, thunders and electric discharges occurs, no, that time what will be, nitrogen oxide together form as a nitric oxide. Nitric oxide. Okay, in this way this nitric oxide will be. Next, this nitric oxide will be again formed with the oxygen mix. So with the help of this nitric oxide, we again two molecules of the oxygen with the ozonization. With the ozonization, so electric discharge also. So 2NO2 formation takes place. NO, nitric oxide plus 3 molecules of the oxygen, ozonization. With the help of the ozonization, N2O5, pentoxide, nitrogen pentoxide. No? So now water molecule and nitric oxide. Now HNO and HNO2, nitrous oxide. No? So oxide of nitrogen and nitrous oxide, both formation takes place. H2O water molecule plus NO2, nitrous oxide. No? Now nitrous oxide and now nitrous oxide and nitric oxide, both nitric. So now nitrous oxide, nitric oxide, both formation takes place. Hydrogen molecule as well as nitrogen pentoxide together form as a 2 molecule of now H2O, N2O5. So water molecule and nitrogen pentoxide, in 2 molecules NO3 formation, means nitric oxide formation takes place. Like the several reaction takes place and different compounds formation takes place. So one after other. Now industrial fixation. Now industrial fixation occurs. So here what will be, directly hydrogen molecule and nitrogen molecules. Water molecule, hydrogen molecule and nitrogen molecule direct will form as a ammonia, high temperature and high pressure, high pressure, under high pressure and high temperature. So we will get the ammonia. So industrially we will get the in this way ammonia, direct hydrogen molecule and nitrogen, means water molecule and nitrogen together gives rise to the ammonia compound. Various fertilizers also produced industrially to supply the nitrogen to the plants. So in this way, different ways, this ammonia formation takes place. As of now, mechanism of nitrogen mechanism of biological nitrogen fixation. So that is first one, nitrogenase. Nitrogenase, an enzyme required for the fixation of nitrogen. So first one, these are required for as a reducing power. So reducing power, for as a reducing power it needed. So in this way, nitrogen weakens the bond between the nitrogen. So this is weakens the bond between the two molecules of nitrogen. Compound for trapping the ammonia for released by the dinitrogen. So for this, so for the trapping of ammonia. So the by released by the dinitrogen. Ammonia, no. So this compound by releasing the dinitrogen. CoA, TPP and inorganic phosphate, MO, magnesium and iron and cobalt. These are required for the nitrogenase enzyme for the fixation of the nitrogen. So these all are required for that. Nitrogen weakens the bond between the nitrogen. So this is weakens the bond between the two molecules of nitrogen, which act upon the hydrogen and form imide, hydrazide and ammonia. So these three are forming after this action of the nitrogenase. So diamide, hydrogen and ammonia, these three are formation takes place. The overall reaction takes as shown in the figure. Nitrogen, 8 electrons, 8 protons and 16 ATP. As a result, 2 NH3, 2H plus and 16 ADP and 16 PI. So all together. As of now, nitrification. It is produced and readily converted to the nitrates by various microorganisms. It takes place in two steps. First ammonia oxidized. First ammonia oxidized to nitrates and H plus 2 molecules of water and energy, some amount of energy. So ammonia oxidized with the oxygen and it gives rise to the nitrites. There is reaction catalyzed by the Nitrosococcus nitrosomonas aspergillus flavus. First ammonia oxidized with the oxygen and gives rise to the nitrites. Then it turned as a nitrates. Now these nitrates are again oxidized and give rise to the nitrates. So 2 molecules of the nitrites give rise to 2 molecules of nitrate and some amount of energy. So like that ammonia formation takes place. Nitrites, then ammonia become nitrite, then Nitrites become nitrates. Finally, we will get the nitrates. Bacteria performing the nitrification are chemoautotrophs, means using the chemical substances which utilize the energy released during the process of synthesis for organic compounds. Denitrification in anaerobic conditions means waterlogged conditions. No, wherever waterlogging there, the oxygen depleted. So they that condition uh, anaerobic organisms work on the these nitrates convert these organism converts the nitrates into the gaseous nitrogen from the soil. So in this way, the denitrification occurs. Means again, this nitrogen goes into the atmosphere by the denitrification. Nitrification quite opposite. It is contrast to the nitrogen fixation. Means nitrogen fixation occurs. So denitrification means release of the gaseous nitrogen into the atmosphere. From the atmosphere, it comes now that is nitrogen fixation. So it is quite opposite to the one to another. 2NO3 nitrous nitric oxide, next nitrous oxide, then it is converted to the nitric oxide to nitrite to nitrate, then nitrous nitric oxide, then N2O nitrous oxide, then nitrogen, gas and nitrogen. So like that they are converted: nitrate, nitrite, nitric oxide, nitrous oxide, and nitrogen gas. So in this way they are converted to the step by step, step by step. It depletes an important nitrogen nutrient to the plants, that is leads to the solubilization of the harmful heavy metals, as well as acidification occurs and causes the acidification and solubilization of the heavy metals. Denitrification has a role in the nitrogen cycle, as it supply the nitrogen to the its reservoir pool, the atmosphere. Even if occurring the denitrification, again it gets the nitrogen from the atmosphere, because it is like a cycle. So one form to other form they are converting, and they are it look like a cycle. So they are elemental form of nitrogen comes and different form converted different forms, and again goes to the atmosphere like a cycle. This is a nitrogen cycle. So like that, from the atmosphere to soil, soil to atmosphere. So this is in this way the nitrogen cycle occurs. Denitrification occur by the Theobacillus denitrification, Micrococcus denitrificans, Pseudomonas denitrificans. These bacteria involved in the denitrification means they are convert the nitrates into the nitrogen gas into the atmosphere, from the soil to atmosphere. This is about the denitrification. Nitrate is most important source of the nitrogen. It is not used by the plants as such. It is step by reduced to the level of the ammonia before being incorporated into the organic compounds. Nitrate ions, NADPH, H plus electrons. Nitrate reductase, FAD, FMN. NO2, H2O, water, NAD, NADP plus, NO2, H2O, NADP plus. Nitrites becoming nitrates. Firstly, nitrate reductase, an inducible enzyme, favors the formation of reduced nitrate in the presence of reduced coenzyme 7H plus. So gives rise to here what will be, what enzyme, which enzyme will be nitrite reductase, nitrate reductase. This favors the formation of ammonia. Now 2NH3 4H2O and 7NADP plus. Here what will be nitrite, nitrates become nitrate, nitrates become ammonia. It is stepwise manner. So nitrates, nitrites, ammonia. So this formed ammonia not liberated. This ammonia combined with the organic organic acids and form as a amino acids. As discussed in the assimilation of ammonia, no ammonia are becoming the other organics compound, no, like that here also will be changed, means converted, which is utilized formation of the various types of the nitrogen compounds.